We are happy to share some good use cases from our perspective, how that we are leveraging the wireless AI and wireless data science to benefit the largest and the best 4G LTE network in this country, along with these 200 million Verizon users. First, what is data science, right? So everyone started to talk about big data, and most recently, everyone started to talk about AI. It seems AI is the end of the world. It's the killer weapon to resolve everything, to resolve any pain points in mobile operators' data ecosystem. Obviously, it is no, right? And a lot of guys in the past who used to be experts of dashboard development, spreadsheet experts, SQL Server developer, or even a PPT and a graphic designer, moved themselves to the data science field and claim, oh, I'm doing data science. Is it? Definitely no. So from academic perspective, what is data science, right? So everyone in this room must be very familiar with this chart already. It's actually an interdisciplinary domain from those three different spaces. After 2009, a lot of graduate schools in the United States started some new programs, graduate programs, named data science, BI, business intelligence, data analytics, blah, blah, blah. The degree names looks fancy, but in a nutshell, what is data science in here? Actually, it's, again, it is an interdisciplinary domain to combine the domain knowledge from computer science, traditional mathematics and statistics, and SME, which is in terms of our domain knowledge. In our mobile industry, at least for now, we need to place LTE in this bucket, right? And Verizon is going to be the first operator to launch 5G earlier next year. So we are renovating ourselves on the way from LTE to 5G. So in a nutshell, at the end of the day, what is wireless data science to a mobile operator? We want to go to this chart to conclude that the wireless data science is to combine the domain knowledge from traditional computer science under the big data environment, still traditional mathematics and statistics. And finally, it is our domain knowledge here, which is on the way from 4G to 5G. Definitely, you can also find a difference in the overlapped area between computer science, mathematics used to be machine learning. Right now, we also escalate it or we evolve it to artificial intelligence because big data make it happen. We have the capability to run our algorithms in such a big data environment. Artificial intelligence, yes. OK. From this slide, I'm going to share a couple of small use cases with everyone here. This is, we call it end-to-end performance flow in a mobile operator's data ecosystem. Talking about big data, right? Big data normally is divided into three domains: domain O, domain B, and domain M. O indicates operation domain, M indicates management domain, and the last one, B, indicates the business domain, right? You must be very familiar with TCP/IP protocol also in here, right? So 40 years ago, when the scientists from Bell Labs, from ATT, they started to invent the TCP/IP protocol, OSI, the 7 layers protocol. At that time, what about those 7 layers? Definitely, the foundation layer is a physical layer, no problem. And then we have MAC layer. Then on top of that, we have network layer, which is in here. And we can overlook those presence layers. Those layers are not used too much by industry. And then we can jump to the layer 7 application layer, right? So if we move TCP/IP protocol into our mobile protocol stack. The physical layer is effective to actually, in our mobile space, it is IF layer, right? So those physical layer stats from our chipsets, from the eNode beads, from any given network elements are focused on the physical layer here. The network layer, in terms of the network layer, we have a lot of traffic stats, signaling stats over there. Application layer, layer 7, we have DPI, we have a lot of application service quality-based indicators over there. However, many years ago, when all the scientists started to invent such a protocol stack, they overlooked the interaction between the machine and people. See, so from the foundation to the layer 7 of the TCP/IP protocol, there is no interaction from machine to people. The previous assumption is machine happy, people happy, which means they overlooked the interaction from the application to user perception, and then further user feedback and user action here. Our colleagues in the morning highlight QoE a lot, which is very good, right? But however, QoE, what is a QoE? QoE basically, many years ago, it is just a survey-based subjective score. What does that mean to our network? What does that mean to our device? What does that mean to user itself? And what does that mean to mobile operator? So this is critical that we need to extend the traditional protocols onto the people layers. That is what we define is from P2P, the new P2P, from packet to people. And see, if I'm a mobile user, no matter which operator that I use the network, see, I'm from Verizon, I use TMO network, I use ATT network. Say I'm a layman, I have no background and domain knowledge on network. What is my user perception? What is ISRP to me? What is SINR to me in physical layer? I don't understand it. I have no direct perception on those physical layer data in here. How about network layer? What is IRC connection success rate? What is the EREP success rate to me? It has nothing to do with my user perception. I, as a human being, the only touching point that can generate my user perception is at the time my finger, my ear, my eyes have interaction with my smartphone, which means in the application, all these application indicators that can be perceived by a human being will generate the direct interaction to user perception. Based upon the user perception, good or bad, I will have my user quality of experience. So there is a need for us to extend the traditional 7 layers onto user layers. That is the key points that we want to make in here. And what about the user perception? After I have user perception, I generate my service quality of experience. What does that mean to Verizon? What does that mean to any mobile operator? The what-if scenario is if my user quality of experience is bad, I definitely, from my user perspective, I need to file complaints to Verizon, to the mobile operators. So the data in the user feedback layer becomes very important. That is a receiver from the mobile operator's perspective to perceive user feedback. So the data in domain business from most typically from user customer care center in any given mobile operator becomes very important on top of user perception layer. And the next what-if scenario is, what if my concern is not addressed by my operator, serving operator? I will take action. I can churn out to Sprint, to TMO, to ATT. I can switch my service plan. Right? I can take any actions. I can return my device. I can withdraw my service plan. So the top layer is about the user action. So the data in the user action will finally feed back to the physical layer. In this case, the first 3 layers, along with the people layers, will be, we call it end-to-end performance flow in our data ecosystem. That is about the data in mobile operator. Some use cases. Everyone starts to talk about artificial intelligence. Every slide deck, every topic, every conference talking about AI. But really, at the end of the day, how many use cases have you had that we have applied to our network? No, I don't think so too much, right? Let's look at the first half of this figure, right? That is a dog photo over there. Google, Facebook, or the other IT companies, right? They do the image recognition through deep learning, right? What can we do? Can we do something from mobile operators' perspective to leverage deep learning to better understand our 4G and 5G network? This is a use case that we have applied to our network, right? Every system performance or network engineer understands the KPI portfolio for each network element very good, very well. So take a look at all this KPI portfolio, let's say from the physical layer until the application layer, right? And also we have very good, thanks the help from the vendors, you have very good OSS system, you have very good data ecosystem to help us collect the data. After you collect the data for us, what can we do from mobile operators' perspective? What we do is every KPI is viewed as a time series in the temporal space. We have KPI from one till last, right? Each sample point in the temporal space is effectively viewed as a RGB matrix in the photo. In this case, we draw a picture of the node B. We draw a picture for a cell site. We draw a picture for every given network element in which we apply the deep learning neural network to profile the traffic and the application characteristics for each given network element in our 4G networks. And of course, for the future in the 5G network. So this is very typical use case that we first leverage the deep learning-based neural network to profile our network, to study the traffic characteristics, traffic and application characteristics of our network element. This is about QoE. So this is a very good transition, actually following the topic in the morning from our Nokia colleagues. One of the pain points is the scalability of the QoE. Traditionally, we leverage our MOS standard, whatever is either from industry or from a particular vendor, embeds the formula into the particular device, and we do the drive test to collect the MOS score, right? How can we actually expand the scalability from a particular drive test to the entire network? What we do is we build our QoE, Verizon's own QoE portfolio in a nutshell. For example, for VoLTE, we call it VVQ. For Real Wi-Fi, we call it Verizon Real Wi-Fi Quality, VVWQ. And this is an award-winning invention last year for the Telecom Innovation Awards by Fierce last year. What we do is we honor the existing MOS standard from ITU. However, we want to, let's say from network perspective, we want to set the inputs and the independent variables which can be collectible from the network and the device end as independent variables for us to fit into a black box in terms of algorithm engine to derive a MOS score. Mathematically, it should be very, very close to the standard MOS score. In that case, we can expand the algorithm portfolio to the entire network, which means the necessary independent variables that can be collected from LTE network will be fed into our algorithm engine to derive the QE score for every session, for every user, at any given location, at any given time. So we leverage this invention to address the pain point of scalability of QE. That is the QE portfolio in Verizon, that we leverage the machine learning algorithm to expand the scalability. Sun. It's also a good transition following the topic in the morning. Sun is well defined by 3GPP 32.500 already. But as you know, the traditional Sun, a lot of series about the auto neighborhood configuration, about the mobility parameters optimization, all these rules, let's see. I first set my target. I want to improve the performance, network performance in terms of what? In terms of, let's say, KPI 1, call job rate. Then I'm able to have a handcraft or hard-coded rule. Let's see. I pick up the InnoDB engineering parameters ABC through tuning the parameters of this ABC to optimize the target KPI called job rate. This is a very handcraft or hard-coded rule, rather than considering the personality or the individual traffic and application behaviors for InnoDB. Otherwise, let's say, in other words, InnoDB in Manhattan should be very, very different from InnoDB in a rural area. So we need to customize the Sun solution for every InnoDB and every cell site. The most vendors nowadays have their what they call fancy Sun solutions. For example, they apply a global solution. Let's say this is the rule to optimize the call job rate. Okay, I apply this rule to all the InnoDBs nationwide. So in here, we overlook the fact that the personality, I call it personality, otherwise you can call it the characteristics of every cell site and InnoDB are very different. Through studying the application and traffic behaviors, we need to identify the label of this given InnoDB and the cell site to identify the service and the traffic profile. For this InnoDB in this area, their target profile label, for example, it is a VoLTE heavy cell. In there, it is a YouTube heavy cell. In there, it might be a web browsing cell, heavy cell. Over there, it might be a balanced cell. For each different label, we have a way to correlate each label to identify the target KPI or KPI portfolio. So in that case, we customize the Sun solutions from layer 7 to identify the Sun label for each cell site and each InnoDB. And we start from there. After we identify the target KPIs to be optimized by each cell site, we start to identify how the engineering parameters can be correlated to the target KPIs for further tuning and optimization work. So this is more like an intelligence-based Sun solution. It's now in the pilot trial phase, patented and accepted by the IEEE Big Data 2 weeks later. And this can be, from our perspective, this can be a very good extension or enhancement of the traditional Sun 3GPP series. And thank you. And one last slide. I just want to make a comparison here is to follow the topic in the morning about QE, right? So the gap between the network performance and QE. Take a look at these two maps. These two maps are showing in the same area, right? All the InnoDB are green here. Network performance is good. And in here, you see a lot of red beans and yellow beans in terms of quality of experience. So there is a gap in here. That's why we need to identify the bridge between the network performance and the user quality of experience. So what we did actually past is we collaborated with a lot of a few professors in psychology field to identify and derive an algorithm to map the qualitative-based network performance indicators to the subjective-based, user perception-based quality of experience indicators. So this is a bridge, which is very hard for us to set in here. But once we figure out this bridge, it will be, I would say it's going to be a permanent solution to address this gap. Because in the past, right, network optimization, it is network KPI driven. If we just take a look at the individual cell-side KPIs, everywhere it looks green. However, if we identify the user quality of experience in here, somewhere it's red and yellow. What we need to do is after we identify this bridge, we are able to correlate, for example, the inner beats which cover those yellow or red zone area. First, correlation correlates the serving cells and the sectors to the pinpoints over here. And afterwards, we are able to identify which KPIs are killer KPIs to downgrade the user quality of experience. This is more like after you set up this bridge, we do a reverse engineering to look it back. Which KPIs, which cost codes, which signaling stats are the killer indicators to downgrade the quality of experience. So in the future, we can overlook, at the end of the day, we can overlook the left picture. So as our colleagues in the morning said, everything can be QE driven in the future. So if we take a look at the GeoBeam-based QE mapping here, we can identify the pinpoint and the hot zones over there and do the reverse engineering to identify the killer stats to downgrade our user quality of experience. So this is some ballpark idea that we are doing. Share with everyone. Thank you.
Any questions? No? Yes, please.
I have a question. So the QE, to solve that problem, to identify the problem, you have to know exactly the information, right? So there
1 moment.
How do you solve that problem?
This is a very good question. This is a common problem across all the mobile operators. The traditional method is mobile operators have measurement reports, MR reports, in the wireless side, in the IF side. Normally, a lot of vendors have their solutions called triangulation to positioning the user location. But that 3GPP suggested method is just a FYI purpose. The error rate is high. Your actual location might be here, but the triangulation may tell you it's over there. That method is not good. Another method is called footprint library. We have a way to pass the HTTP packet rather than HTTPS. A lot of apps in terms of HTTP can be parsed. For example, there is a very famous app called Didi or Uber, right? A lot of user location-based apps which are based upon HTTP encapsulation methods, literally, that we can that we can leverage this HTTP-based app to pass their let-alone data. That is called footprint library. But we understand more and more apps are moving from HTTP to HTTPS. This is just an intermediate methodology for us to get the most user location. A third way that I want to put in here is we want to leverage the state-of-art AI, machine learning, or data mining algorithm or methodology to improve the traditional methodology of triangulation. I foresee there is some space for us that we can leverage AI algorithm to improve the traditional triangulation method. Yeah.
Okay. So I think, for the interest of time, we have to move to the next presentation. So thank you very much, Dr.
Sure.
Ye.
Thank you.
That's fantastic insights.